So let's look at the numericals of structure of atom and nuclei. First sum, determine the series limit of Balmer, Paschen and Pfund series given the limit of Lyman series is 912 Armstrong. So for an electron jumping from mth orbit to nth orbit, the photon released has a wavelength which is given by 1 by lambda equal to r into 1 by n square minus 1 by m square. In order to get the series limit, we need to put m as infinity. So the formula becomes 1 by lambda equal to r into 1 by n square. For Lyman series, the series limit is given by 912 Armstrong. Therefore, 1 upon 912 into 10 raised to minus 10 meters will be equal to r into 1 upon 1 square, that is 1. So we can write it as 1 by r equal to 912 into 10 raised to minus 10 meter. So using this value of 1 by r, let's calculate the series limit of Balmer, Paschen and Pfund. So for Balmer series n equal to 2. With it we get the formula as 1 by lambda equal to r upon 2 square, that is 4. So our lambda becomes 4 divided by r, or you can write it as 4 multiplied by 1 by r, and we know the value of 1 by r as 912 into 10 raised to minus 10 meters. So 4 into 912 into 10 raised to minus 10 meter. That is, for Balmer series, the series limit we get at wavelength of 3646 Armstrong. Similarly, for Paschen, n equal to 3, which implies 1 by lambda equal to r divided by 3 square, that is 9, which implies lambda equal to 9 divided by r. Therefore 9 into 1 by r, and 1 by r is 912 Armstrong. So 9 into 912 into 10 raised to minus 10 meter. So lambda we get as 8204 Armstrong. Now let's see the series limit for Pfund series. So for Pfund, n equal to 5. Therefore 1 by lambda will be r divided by 5 square, that is 25, which implies lambda will be 25 into 1 by r, which will get 25 into 912 into 10 raised to minus 10 meters, which implies our lambda will be 22789 Armstrong. Now let's look at the next sum. Calculate the binding energy of alpha particle given its mass to be 4.00151 atomic mass unit. So mass of alpha particle is given as 4.00151 U. We need to calculate the binding energy, and the formula for binding energy is given as E equal to delta M into C square, where the mass defect is given as Z into mass of proton plus N into mass of neutron minus the total mass of nucleus. Now the alpha particle is nothing but our helium nucleus without electrons, that is He2 4. From this it implies that our Z is number of protons, that is 2, and N is number of neutrons, that is also 2, and mass of proton in AME is given as 1.00728 U, and mass of neutron is given as 1.00866 U. So putting all this value in this equation, we get E as 2 into mass of proton, that is 1.00728 U, plus 2 into 1.00866 U, minus 4.00151 U into C square. Now taking all the U's outside and multiplying this, we get 2.01456 plus 2.01732 minus 4.00151 U into C square. Now one thing to note here is that 1 AMU is equal to 931.5 mega electron volt by C square. So automatically 1 U into C square will be 931.5 mega electron volt. So multiplying at end with 931 mega electron volt, we get the value as 0.03037 into 931.5 mega electron volts. So finally we get the binding energy as 28.29 mega electron volt. Let's look at the next sum. An electron in hydrogen atom stays in its second orbit for 10 raised to minus 8 seconds. How many revolutions will it make around the nucleus in that time? So here they have given us the second orbit, which implies n equal to 2, and that in that second orbit the electron stays for 10 raised to minus 8 seconds. So time is 10 raised to minus 8 second, and we need to find out that how many revolution will it make around the nucleus in that time. So in order to calculate, we need to first see that what is the time period for one revolution, that is t equal to how much. So we know that v equal to r omega and omega equal to 2 pi by t, which implies t equal to 2 pi by omega, and omega is from here v by r, right? So putting the omega value, we get t equal to 2 pi v by r. So by substituting the value of Vn and Rn for an electron in nth orbit, we get time period as 4 n cube h cube epsilon naught square upon z square e raised to 4 m. For hydrogen atom, z equal to 1, and we are talking about the second orbit, so n equal to 2. Putting this value in here, we get t equal to 4 into n 2 cube, that is 2 cube is 8, into h cube epsilon naught square upon z square, that is 1 square is 1 only, so e raised to 4 m. So finally the time period expression, we get it as 32 h cube epsilon naught square upon e raised to 4 m. Now putting all the constant value, we get the value of time period for second orbit as 12.25 into 10 raised to minus 16 second. So the time period is for one revolution. So then electron takes 12.25 into 10 raised to minus 16 seconds for making one revolution. So how much revolution will it make in time 10 raised to minus 8 seconds? So n is equal to number of revolution it makes around the nucleus in that time. So n will be t divided by t, that is 10 raised to minus 8 second divided by 12.25 into 10 raised to minus 16, and calculating it, we get the number of revolution as 8.1 into 10 raised to 6. Now let's look at the next sum. Determine the binding energy per nucleon of an americium isotope Am95 given the mass of americium to be 244.06428 AMU. So we know the binding energy is given by E equal to delta M, that is mass defect, into C square. but we need to calculate here the binding energy per nucleon. That is, per nucleon, in a nucleus there are protons and neutrons, so collectively they are called as nucleons. So total nucleons is nothing but our atomic mass. So we need to calculate the binding energy per nucleus, that is E by A. So here also delta M into C square by A. So the formula for mass defect will be Z into mass of proton plus N into mass of neutron minus the total mass into C square, and the atomic mass of americium is given as 244. So this will become 244. Now substituting the value, we know that this is the atomic number. So number of proton is nothing but our atomic number. So Z will be 95. But number of neutron is A minus Z. That is 244 minus 95, which we get as N equal to 149. So let's substitute these values. So 95 into mass of proton in AMU is 1.00728 plus 149, that is number of neutrons, into mass of neutron, that is 1.000866, minus the total mass, which is given as 244.06428, and taking the mu outside into C square. Now calculating it, we get 95 and this whole thing divided by 244. So calculating this, we get as 95.6916 plus 150.29034 minus 244.06428, and U into C square. From the previous sum we saw it as 931.5 mega electron volt, and this whole thing divided by 244. So calculating it, we get at 1.918 into 931.5 mega electron volt divided by 244, and hence our answer is binding energy per nucleon as 7.322 mega electron volt per nucleon. Let's look at the next sum. Calculate the energy released in a nuclear reaction given by lithium plus proton gives you 2 alpha particle. Given mass of lithium 3 atom and helium atom to be 7.016 U and 4.0026 U respectively. So we need to calculate the energy released in this nuclear reaction, that is the binding energy, which is given by E equal to delta M into C square. But delta M is the mass defect, that is when this reaction happens, the masses on the left hand side is greater than the masses on the right hand side, and the fraction of mass that is lesser in the right hand side of the equation is converted into energy, which is nothing but that energy that is released. So from this we know for lithium the mass is given as 7.016 U, plus for proton we know the mass of proton as 1.00728 U, minus the mass of the alpha particle, twice the mass of the alpha particle, that is 2 into 4.0026 U into C square. So calculating this, we get 0.01808 into U into C square, that is U into C square we know is 931.5 mega electron volt. So 0.01808 into 931.5 mega electron volt, and thus the energy released we get it as 16.84 mega electron volt. Let's look at the next sum. Complete the following equation describing the nuclear decays. So first it is given as radium 226 86. This is not 86, this is actually 88, because 86 is a radon. So let's do the first sum. 226 radium 88 gives you an alpha particle plus X. Now we know alpha particle is our helium atom, that is H24. So if this is 4 and this is 2, so let's balance the equation. So this is 226 and minus 4 we get as 222, and 88 minus 2 is 86. So the element that has atomic number 86 is radon, R, and 86 to 22. So here R and 86 to 22 will come. Now let's look at the second. Oxygen 819 gives you an electron plus. So when an electron is released, we know that this is a beta decay, and when an electron is released, a neutron is converted into proton. So the element that we will obtain will have an atomic number that is increased by 1. So this 8 will become 9, but the atomic mass will be same. So 919 plus an anti-neutrino is released, which has a negligible mass. Let's see the third one. So we have given thorium, that has atomic number 90 and atomic mass 228, which gives you an alpha particle plus nu. So 228 minus 4 and 90 minus 2 will give you 224, and 90 minus 2 is 88. So this is nothing but from our first reaction, radium. So this is our radium 88 224. So here again radium 88 224 will come. Now let's look at the last one. 12 nitrogen 7 gives you carbon 12 6 plus. So in this reaction our atomic number is decreased by 1. This implies that our proton is converted into a neutron. So a positron will be released along with a neutrino. Calculate the energy release in the following reactions given the masses to be. Here masses of all the elements are given which are in this reactions. So we know the energy released is given by the formula E equal to delta M into C square, while delta M is our mass defect. So let's calculate one by one. So for first equation we have E equal to, on the left hand side we have radium. So radium, the mass of radium is given as 223.0185 U, minus on the right hand side we have Pb 88 and carbon 6. So Pb is given as 208.9811. So 208.9811 U plus carbon is given as 14.00324, 14.00324 into C square. So calculating this we get 0.03416 U C square, and U C square is 931.5 mega electron volt. So 0.03416 into 931.5 mega electron volt. So energy we get it as 31.82 mega electron volt. Let's see the second one. So for the second one, energy will be, we have given uranium. So uranium, mass of uranium is given to us as 236.0456 U, minus on the right hand side we have Ba and Kr, that is mass of Ba is 139.9106. So 139.9106 plus krypton, mass of krypton is 930 93.9341 into C square. Yeah, here U and U. So solving this we get 0.18358 into, and U into C square is 931.5 mega electron volt. So the energy that we get as 171.0047 mega electron volt. Let's see the third one. So carbon gives you a boron and a positron plus a neutrino. Neutrino has a negligible mass, so we won't consider it, and positron has a mass of similar to an electron. So the energy is given as carbon 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 611 is 11.01143. So 11.01143 minus mass of boron is 11.0093, and positron has a mass of same as an electron, that is plus 0.00055 into U into C square. So solving this we get at 0.00158 into U into C square is 931.5 mega electron volt. So the energy release is 1.472 mega electron volt.